Hey there, grade 7 students, and welcome to this explainer. Today we're diving into something absolutely foundational, how Python programs actually talk to us. It's one thing to have a computer crunch some numbers in the background, but it's a whole different ballgame to have it ask you for information, make a real-time decision based on what you just typed, and then respond right back. We're going to break down exactly how this magic happens. Here is a quick roadmap for our explainer today. We'll be hitting 1. The Python data journey claim. 2. Receiving values with input. 3. Processing evidence with decisions. 4. Communicating results with output. 5. Testing your Python knowledge. And 6. The final lesson takeaway. Let's get to it. Kicking things off with Section 1, the Python data journey claim, a conversation with code. I really want you to think of Python as having a structured conversation with you. Just like chatting with a friend, the program moves logically through 3 distinct steps. First, it has to listen to what you're saying. Then, it's got to think about that info and process it. And finally, it has to speak back to share its results. Every piece of evidence we pull from the Python documentation today is going to back up this idea of a conversational claim. Moving right along to Section 2, receiving values with input. This is all about listening to the user. So, how exactly does Python listen? Well, it uses the built-in input function. When this function runs, your program literally pauses. It just waits there for you to type something in. But here is a super important detail from the documentation. It reads whatever you type, converts it to a string, which is just Python's term for text data, and it actually strips away that invisible trailing new line that gets created the second you hit the enter key. It then returns that nice clean string of text back to your program. Now here is a massive trap a lot of beginners fall into, a real misconception. Let's say you use the input function to ask for an integer. Because of what we just learned, even if you type the number 42, Python still sees it as the word 42. It's just text, and you definitely can't do math with text. So, if we actually want to process a number, we have to wrap our input function completely inside the int function, which stands for integer. This takes that captured text and safely converts it into a usable number so our program can do some real thinking. Which brings us to Section 3, processing evidence with decisions. Thinking about data. All right, let's look at this model decision straight from the official docs. In step 1, we receive the integer and assign it to the variable x. Now the thinking begins. In step 2, we use an if statement to evaluate our first condition. Is x less than 0? If it is, we change it to 0 and prep our message. If it isn't, we move down to step 3. Here, we use an elif branch to check a brand new condition. Is x exactly equal to 0? Finally, in step 4, if absolutely none of those conditions were true, our else branch catches everything else, deciding the result must just be more. And that example brilliantly illustrates how the elif keyword works. It's literally just short for else if. If you're comparing the same exact value to several different constants, using elif keeps your code super clean and avoids excessive indentation. Instead of nesting if statements over and over inside of each other, which, let's be honest, gets really hard to read, elif lets you list your decisions out in a clear, flat sequence. On to Section 4, communicating results with output. This is where Python starts speaking back. Once the heavy lifting of thinking is done, the built-in print function is the tool that handles our output. Notice the connection here. Just as input brings text in, print pushes text out. It automatically converts the arguments you give it into strings so they can be written to the text stream. Practically speaking, that means displaying it right there on your screen, with all your items neatly separated by spaces. But we can actually make this so much better. For fancier output formatting, Python gives us formatted string literals, or as we usually call them, f-strings. To make one, you simply begin your string with a lowercase or uppercase f. Then, the magic happens. You can write actual Python expressions, like your variables, right between curly braces inside the string. It is an absolute game changer for seamlessly injecting your processed data directly into the outgoing text. Here is a perfect example of this in action from the documentation. We've got a variable year set to the integer 2016 and event set to the string referendum. By using an f-string, we just pop year and event right into the sentence. Python does all the hard work in the background, converting that integer and combining it with the static text to output a beautiful, human-readable sentence, results of the 2016 referendum. Section 5, testing your Python knowledge. Time for a quick retrieval check. Based on all the evidence we just covered, I want you to imagine your program has processed some data and stored it in a variable. X equals 42. Think about how you would format the output to inject that processed variable directly into a printed sentence. Take a second to mentally build that code. Remember, you're going to need the speaking function, the formatting letter, and those special braces. Did you get it? Exactly. You use the print function to initiate the output. Inside the parentheses, you start the string with an F. Then you write out your text and place the variable x securely inside the curly braces. That tells Python to swap in the number 42 right before speaking the sentence back to you. And finally, Section 6, the final lesson takeaway. Let's look at the reasoning behind all of this. So let's tie this whole claim, evidence, reasoning sequence together. Our claim was that Python runs a structured conversation. The evidence from the documentation backs this up perfectly. The input function listens for strings. Conditional decisions like if, elif, and else give the program a way to logically think, and print paired with f strings allows it to speak back dynamically. The reasoning here is that Python's syntax links all these steps in a really safe, predictable way. It requires us to intentionally convert incoming text to integers before we process it, and then perfectly formats those results back into text for a seamless output experience. This is really just the beginning of what you can do. Keep exploring these foundations, poke around in the documentation, and think about the amazing interactive programs you can create by having Python listen, think, and speak. So what kind of structured conversation are you going to build next? Thanks so much for joining me on this explainer, and happy coding.